And so to just quickly finalize this, what I'd like to do is that I'd like to just find out where my project location is on this drive, okay, and just jump to this location. Okay, so I have it right here, so I'll just create new header, and I will call it I don't know, silly name, my classes, right? My classes. That is just an example of what I could do here, right? So just create the header file, drag and drop over here. And basically, what I can do then, I can move these definitions of my classes, engine, wheel, scooter, rider, all of these guys, right? I can move this out to my classes header. Of course, in this header, I need the header guards, right? So typically, you would like to derive it from the name of your header, right? So we can say copy full path over here, right? And we can say if not defined, this thing that looks like my classes. Just resize this a little bit so you can see what's going on. Included, right? Something like this. Make it uppercase because this is a preprocessor macro. We can say define, right? And define it immediately like this. And at the end, we wanna, at the end of this header file, we wanna say and if, right? And you can add this as a comment at the bottom of it. And of course that now I have a silly name of my header like my classes. Now I can go to just move it to a separate tab. Actually, let me move this to the new vertical tab like this. And of course over here I would say include my header, or I call this my classes, right? My classes, which is a silly name, but this is for the sake of demonstration that most likely you would like to keep subsystems described by your classes in separate headers, right? So if then I wanted to keep the rider away from here, I could create yet another header file. So this is a comparison to Java work when we create. So the rider can live it in its own header class right here. Wait a minute. Meant to make it .h, not .k. Rename one more time, .h. Okay. So again, the same routine, right? So we just basically create another header like this, and this way, if you wanted to move this rider out over here and have it in a separate class, again, you normally would want to use the name of your header file. Okay, and then just resize this a little bit. Okay, so right here we're gonna say the same thing as we did over here, right? So be careful. It's easy to copy and paste these header guards at the top, but be careful. You need to use this unique name over here, right? Because all header guards should be unique and consistent with the names of your header files. So if you're using C++ as your platform, just be aware that you can do all of this, okay? And of course, the problem is that now, if we have this header file, right? So we probably want to in this rider.h, we probably want to create this my classes. I mean, want to include my classes over here, right? So in the rider, we want to create, we want to include engine and the wheel and the scooter classes, and then here we can simply then include the rider to do the same type of work, right? So basically now the rider header file includes all of the rest of the classes. And of course, this name is really silly, but I just don't have a better idea how to name it, right? So if we rename it, we will have a burden of renaming this, right? Renaming the file, and then changing all of the includes, right? So more manual work. But things like this are not uncommon because, you know, if you have everything in your main file or someplace similar to this, it's just not very practical. You want to be able to basically move your, move your classes around and store them in multiple files. The only thing to remember, it's in any kind of project that you do, is that you really, if you go back to your project structure, only implementation files should be included on the list of your source files in your C++ project. The header files are really managed by the preprocessor, which runs before compiler will see your code, and therefore all includes will be resolved before the compiler. So therefore, never include header files on the list of your source files. That's completely, it's wrong and it's unnecessary, okay? And so that would be something to mention about this. And finally, if you really wanted to, take care of nicely designed interfaces for your classes, what you can do in C++, you can separate the implementation from the actual class definition. And I'm talking about implementation of constructors and methods. Well, right here, all of my constructors are very, very small, so that would probably be somewhat impractical, but I guess I can demonstrate this very quickly with this my classes. So I could create another file, name it my classes .cpp, which would be an implementation file, right? And then drag it over here so that we can start working with this empty file, but we will include it on the list of source files, right? So we can say add the existing item, which in our case will be a new implementation file. Add that, right, to the list of source files right here, right? So now I can close this, and so this time what I want to do is, of course, I want to include my classes to work with. Include my classes.h over here, and perhaps I can provide implementation of this engine constructor. Basically copy and paste this and qualify it with the class name like this, and then provide the implementation, maybe just align it a little bit, and then similarly use constructor for the scooter also in this file right here. Okay, just paste this one in as well, and I have to provide the name of the scope where it's coming from, because it's the constructor that belongs to the scooter class. All right, and over here, if I did this, this can be reduced just basically just to a method declaration, and arguably and truly, this makes declarations of your classes in C++ much more readable, right? Because you essentially have only the data types and the names of your classes to deal with. So just doing this simplifies understanding of what those classes are, right? So in C++, the implementation of your member functions, including constructors, can be done elsewhere in a separate file. All you have to do is essentially just use the name of your member qualified by the name of the class, and this thing is called scope resolution operator, which indeed tells that engine is the constructor inside the engine class. Okay, so that would be the thing to see this. Perhaps unnecessary in this little project, but it would make sense to do this in a larger project when you actually start to add, functions, other member functions to your classes. So that sort of like concludes a set of demonstrations for today. In Java, we have no choice but to write code in line. So if I have the scooter and I decided to have two constructors inside the scooter, I need to be able to do this in line. So with just this quick overview of, and comparing the decision making and the direction in which you would be normally going with your application in C++ and Java. However, the design like this design is language neutral. You can see that I'm working with the same design in C++ or in Java, or I could use a different programming language to do that, right? So this is truly, so UML version of it, of course, we should probably mention UML, right? So we're using UML to draw our design diagrams over here. So this would be our unified modeling language. Idea here demonstrates that UML is language neutral. As long as you have a language which supports object-oriented programming principles and features, this could be taken over, and the actual implementation can be written for it.